Mr. Nelson is distributing colored markers to a group of children. If he gives each child 4 markers, he will have 3 markers left over. In order to give each child 5 markers, with no markers left over, he will need 17 additional markers. How many markers does Mr. Nelson have? So that's the question. For us to solve this question, we need to take note of 2 key variables. One is the number of children. So let's say let the number of children be C, because we have children, so I want to use C. I like using variables that are logical to a question, and we can say let the number of markers be M. Now we've identified our key variables, we can go ahead to create an equation to solve this question. This question is under systems of linear equation word problems, which is same as simultaneous linear equation word problems. Assuming Mr. Nelson starts off with M markers and he give each child 4 markers, so it means he's giving away, so that's -4. He's giving each child 4 markers, as you can see here, and then he will have 3 left over, so he will be left with 3 markers. We can call this equation 1. In order to give each child 5 markers, so starting off again as M marker, he's meant to give each child 5 markers, okay, with no markers left over, which means 0 markers will be left over. He will need 17 additional markers to make this possible, so let's call this equation 2. Now we've identified equation 1 and 2, let's go ahead and make M solve the formula in equation 1. For equation 1, M minus 4C is equal to 3. Let's move 4C to the right hand side by adding 4C to both sides. So that simply means M is equal to 3 plus 4C. Because negative 4C crosses over to the right hand side, it becomes a positive. So this is the modified version of our equation 1. Then let's go ahead and make M solve the formula in equation 2 also. So M minus 5C plus 17 is equal to 0. We are meant to move negative 5C and positive 17 to the right hand side. So we'll have M is equal to 5C minus 17 because it's crossing over. So you can see what the modified version of our equations look like. Now we have M as sort of formula in both equations, we can make them equal to each other. So equation 1 equals to equation 2. That becomes 3 plus 4C is equal to 5C minus 17. Now we can move negative 17 to the left hand side and move 4C to the right hand side. This is more like collecting like terms. So 3 plus 17, because it's crossing over. Remember, when a value crosses the equality sign, it changes its sign. So if it was a positive value, it changes to negative, and if it was a negative value, it changes to positive. And here we have 5C minus 4C. 3 plus 17 gives us 20, and 5C minus 4C gives us 1C. So that's just C, because in mathematics we don't have anything like 1x or 1y. It's just x, y, or C based on the variable. So therefore C is equal to 20. Now remember, what is C? C is the number of children. That is not what we are meant to solve. We're meant to solve for how many markers, and that's M. But for the fact we have C, that's a big achievement. Let's go ahead and solve for M. To solve for M, you have to substitute C into any of the equation, whether equation 1 or equation 2. So we can say, continue from here, substitute C into equation 1. And I want to use the modified version of equation 1. You can as well use the original version, it doesn't change anything. That is, M is equal to 3 plus 4C. M is equal to 3 plus 4 bracket C is now 20. So M is equal to 3 plus 4 times 20 is 80, and then m is equal to 3 plus 80 is 83, which means Mr. Nelson had 83 markers initially. So he started off with 83 markers. Okay, so let's make more sense out of this. So let's check. 83 plus 17 gives us 100. And they said for the second equation, in order to give each child 5 markers. So let's do 100 divided by 20. That's the number of children, because now we know he has a total of 100 markers. So let's divide it by the number of children, which we solve for as C. And 0 cancels 0. 10 divided by 2 is 5. So which means 5 markers. Makes sense. So he needed 17 additional markers for him to be able to share 5 markers to each of the children without any remainder. So he had 83 markers and needed 17 additional markers. The right option is option C. I hope this makes sense to you. Do well to like and subscribe so that I can keep getting this kind of amazing and interesting maths lessons or question review. Thank you.